Thank you. Yeah, so who will be the reviewer today?
So it's my paper presentation today. It's
Okay,
Rohit.
okay, so then I'm going to once again share the paper review peer evaluation link in the chat box. And you can start anytime, Rohit.
Okay. Can everyone see my screen? Okay. So my paper presentation is basically on additive manufacturing as enabling technology for digital construction as a perspective of construction 4.0. As we were discussing in the previous guest lecture, like how is it going to enhance our construction productivity? So my topic is basically over that. So as we see, according to the reports published by World Economic Forum, the construction industry currently accounts for 6% of world's GDP and is expected to reach about 14.7% by the end of 2030. Construction is a strategically important sector for many countries around the globe. Well, according to World Economic Forum, as a 1% rise in productivity worldwide could save about $100 billion a year in construction costs. That's a lot. The construction industry generally consumes very significant proportion of raw material produced around the world. Using, for instance, 50% of global steel production is utilized by construction field itself and is responsible for about 30% of greenhouse gas emissions as well. The population living in urban areas is rapidly increasing, which impacts the need for affordable houses. And this is where our construction 4.0 comes into picture. So advanced technologies mostly commonly used in manufacturing sectors are being exported for construction and architectural applications. However, contrary to other industries, construction has been slow to adopt new technologies and has never undergone a major disruptive transformation. As we are learning in this class, that it's pretty difficult for us to transform, and that's what's happening right now. The other industrial sectors are not showing the same path as though, like automotive and aeronautics are undergoing a radical process change by adopting to digital technologies and everything. The industrial transformation is driven by shift towards a physical to digital to physical connection enabled by user, sensor and controls, augmented reality systems, cognitive and high performance computing, additive manufacturing, advanced material, augmentatious robots and digital design and simulation system among some of the technologies which are part of construction 4.0 right now. So these are few pictures of how 4.0 is like additive. This thing is working right now. Productivity reduces project delays and cost overruns, managing complexity and enhances safety, quality, and resource efficiency. According to report from Boston Consulting Group, within 10 years, full-scale digitalization in non-residential construction will lead to annual global cost savings of 13 to 21% in the engineering and construction phase and 10 to 17% in the operation phase. This paper particularly discusses about the digital transformation of construction sector, in particular the potential of additive manufacturing for building construction as key enabling the technology of 4.2. The search was focused on subject fields of architectural, engineering, and construction, that is EEC, involving data from primary and secondary sources. The keywords included in this particular research are concrete printing, 3D printing in construction, or as we call it, AIM, additive manufacturing in construction, and digital construction and construction 4.0. Additive manufacturing technologies being developed for construction are described well measured and opportunities. Detailed discussion for technology concepts of construction 4.0 included such as logistics, sonar, sensors, IoTs, and cyber physical systems are outside scope of this review. Using sensor technologies such as thermography, as well as promoting collaborative designs, developments, and construction projects. 3D laser technology enables to digitally capture structures, water pipes, uploading this data into digital planning tools for teams to work on beam. Like right now, I'm also getting this particular course from Dr. Eric, where we are learning about the MEP part of a building, where we are using beam as a modeling tool. So integrated cloud computing technologies with Beam allows project stakeholders to work in real time and close to collaborate from different locations. Cloud Beam can be accessed by mobile device such as smartphones or tablet PC. Like we can access it from anything. In addition to Beam, the Internet of Things is another technological development with potential to transform building industry right now, which we are learning in this course. In construction, IoT technologies and applications can transform construction of new buildings as well as maintenance and operation. Conversely, real-time information and diagnostic data is critical for predictive maintenance decision-making of mechanical assets such as heating, ventilation, and air conditioning, that's HVAC systems. The emergence of IoT technologies, cloud computing, and being produces huge amount of data, and thus requiring a big data technology involvement in this construction 4.0 as well. So additionally, we are adding technology to this field, and one of the additional technology will be unmanned aerial vehicles, or we call it UAV, also called as drones, and increasingly use of AEC field having ability to capture large amount of data through multiple sensors such as cameras, laser scanners, radio frequency, that is RFID readers. UAVs are used for tracking progress of construction projects and making quality. So this particular picture shows how's construction 4.0 going right now, like everything about it and how we are advancing in it. So furthermore, apart from monitoring building sites and realizing the dangerous tasks, this way increasing workplace safety as well. Like as we saw in the previous picture shown by Dr. Cheng, that in 1910 people used to sit on a bar and used to like safety wasn't the main concern, but now we are getting into it. So transformation of construction industry into digital and innovation based sector will drive construction towards the application of automated modeling and manufacturing process. So now discussing in detail about additive manufacturing in construction. So AM is defined as the process of joining materials to make objects from 3D model data, usually layer upon layers as opposed to subtractive manufacturing methods such as traditional machining or STM they call it. M was initially used to produce conceptual product models for aesthetic and ergonomic purposes, identifying design flaws and testing the product during design process. Actual product manufacturing is increasing, and toys, furnitures, automotive and aerospace productivity and medical devices are among many items being produced with this technology. So basically, right now, 3D printing is mostly utilized in the sectors such as aerospace, architectures, and medical fields, where they try to solve out the design flaws and try to make it perfect. So this is what happening right now. Uh, so computer model is first generated using CAD systems and being tested and converted into a standard file format. It's called as STL format. multiple cross sections that are sent to the AM model. The CAD model must be a 3D solid using either constructive solid geometry, that is CESG, or boundary representation, or BREP. The STL file format is a conceptual, simple and easy way to generate but present problem related to its size and numerical accuracy. It is also not possible to specify material properties, so the fabrication, which is important drawback of M, has high potential to produce heterogeneous structure with varying materials or densities. So fabrication process can be controlled based on vector moments like straight lines, curve, approximated on segments, or a raster individual dots like monotone bitmap. Due to specific nature of each technology and type of material and size of building elements, the M process used to construction sectors are mainly extrusion based and binder jetting. So these are few examples of 3D models which I'm showing you right now. So these are STL, this is CAD, and this is SLI. The control crafting process, one of the first M technique proposed by construction industry, was developed by Koshnoviks. The contour crafting process has been used to extrude concrete or ceramic paste material through 3D printing heads mounted on an overhead crane. For fabrication of doors or windows, a lintel is placed to the bridge. The gap between the walls and upper part of the wall is printed on top of this lintel. The crafting technique has been validated through construction of small scale structures and housing scale walls, and successfully produced wall elements of 2 meter high with a width of 13.5 centimeter at a speed of approximately 1 square per meter per hour. The other techniques similar to countergrafting from commercial or academic application developed by different companies research groups such as Vinson in China, Total Custom in USA, BetUrb in Slovakia, Conprint 3D in German. So these are few pioneers in the field of 3D printing right now, and they are also working. So Vinson, a pioneer company in this field, has successfully printed a group of 200-meter square houses in 2014 and uses largest system to print building components and assembling them at construction site. So these are few of their houses they have assembled until now. The fabrication process includes two main steps. Firstly, mortar premix with appropriate rheological behavior is prepared and kept in shearing mixer. The premix is pumped to a screw-assisted printhead using peristaltic pump. The additives are simultaneously dispersed into the mix to accelerate the setting of mechanical properties after extrusion. Shows an example of 3D printed concrete multifunctional wall produced by Gosselin and co-workers. So Saib and Arup have recently printed a 100 square meter of concrete house made by 35 modules of fully printed in within 48 hours, while in Brill, Netherlands, using robotic arm, produce high quality facade elements with gradings of color. So this is what the technology is moving right now, like, and this is how basically the printing has been transferred to the sites and transported. These are again a few examples of how printing frames of concrete printing looks like, and this is one of the printed wonder bench around over here. Recently, this group produced bridge with a span of 6.5 meters and 3.5 meter and a width of 3.5 meters, and it was composed of six printed elements traced together by post-tension and pre-stressing tendons. A specific nozzle was developed to deliver reinforcement cable together with extruded concrete. So they're also dealing in pre and post tensioning work of the structural part with the help of 3D printing right now. So yeah, it's developing pretty good. Advanced Architecture of Catalonia, or IAAC, developed the concept of mini builders. So basically, in mini builders, they use three small robots which are capable of printing concrete. In this case, one or two or more foundation robots are created. The footprint of the structure followed by grip robot clamp on footprint to produce structure using as support the previous printed layers. The grip robots are capable of printing ceilings and lintels horizontally. Uh, so after that, so this is how the whole development has been going on right now. In Zurich, a patented fabrication process called smart dynamic, that is casting, where small formworks of compared to produce structure is attached to a six-axis robot arm and is programmed to move vertically. So like they are even getting into formworks right now. So that is pretty cool. So polymer-based materials, extrusion-based systems were also used by Dutch companies called DUS Architects and Partners in Amsterdam to print large polymeric components up to 2 into 2 into 3.5 meters for a project named 3D Print Canal House. And this is how a typical schematic of 3D printing setup looks like, as you can see in the picture, and the end product is a properly created 3D model. So, this is also called as contoured model, where it's contoured one by one and then a 3D model is developed. These are few 3D models again and how they look like. So moving on, in 2013, Skanska was pioneer in using 3D printed parts for 6 Bevis Mark's office project in London. The junction between the roof supporting steel structure and columns received ethylene tetrafluorobene cladding piece produced by AM. So even Skanska is getting into this technology right now, and so there is development over here. Again, this is how the mini builders work. This particular image shows, and this is smart dynamic casting. So construction materials with possible use in earth construction and potential disadvantage for planetary construction such as on Mars, where it is abundant and safe to use due to range of temperatures in those planets. Like, so 3D printing is also going to be a part in future for construction on Mars or any other planets right now. So that's going to be something way better in terms of technology. So in situ retrofit or repair technologies, most of the 3D printing technologies developed for construction industry are used to build new buildings or part of the buildings and civil infrastructure which are needed to maintain, repair or retrofitted. Reverse engineering technologies such as laser scanners, infrared thermography and photogrammetry have been used to develop in situ printing models adapted to existing construction. So this is how normally the robot arm works around in 3D printing. So this shows about about the foam concrete, and the second image shows about cementitious material incorporating fly ash and censorship. The binders, initially based on epoxy and polyurethane materials, were gradually replaced by more eco-friendly and organic binders, as we are going eco-friendly right now. Emerging Objects USA developed a rapid concrete masonry unit that uses inkjet sprays to bind fiber reinforced cement mixture with small size aggregate. So even they are able to bind aggregates with with the CMU units now. So that's something good. So TU does then has a project on 3D printing of steel reinforcement bars using gas metal arc welding equipment together with 3-axis CNC system. The result shows reasonable bonding between steel bars and concrete elements. Max 3D from Netherlands printed a fully functional steel bridge with using similar welding machines coupled to robots. So basically, we are able to even build steel structure using 3D technology right now. And fusion of technologies were used to produce glass objects using both natural energy from sun and sand. So these are a few detail of printing processing where binders are sprayed and printed and structures by emerging objects. So this is one of the 3D printed glass column which I'm on which my mouse is hovering right now. So this is something which is getting into. So materials using AM as a platform for material design allows us to use natural and recycled materials, contributing to more sustainable construction approach, which is one of the target of construction 4.0. Most research groups are exploring AM for concrete printing, though for functional extrusion of concrete, it is important to improve fresh properties. So here's a basic concrete printing how it goes. Materials used for concrete printings, like raw materials such as recycled glass, sand, cork, additives like superplasticizers, accelerators, and retarders. So this is how the diagram is. Moving on, the lightweight and functionally graded structures. So as we are moving forward, it is fundamentally to actively seeking for reduction of CO2 emissions and encouraging energy efficiency. A resource efficient construction sector with lightweight structural component will help to reduce waste generation, emission, and global resource of consumption. On the other hand, thin slash light walls avoid overloading of building structure, reducing cement consumption, which is responsible for production of approximately 5 to 8% of CO2 worldwide. So it's helping us in lot many cases by bringing down gases as well. So research challenges and conclusion. M is evolving as a transformation technology for construction sector, allowing architects and engineers to design more complex geometries. Some groups adapted existing systems such as extrusion and binder jetting process to print concrete or polymeric construction elements. Gradually, medium and large scale systems have been developed focusing more on on site applications. More technologies need to be developed using in situ resources. There are few things that need to be improved. So printing time must be reduced to avoid premature solidification of printed material and clocks inside 3D printing machine. For multi-material disposition and multi-print head and multi-gantry systems, the deposition flow rate must be precisely controlled, and printing flow should start and stop at time to avoid material accumulation at specific areas. Finishing operations must be considered in production process since most of the current technologies print element with a rough appearances. A real-time feedback of printer is fundamental to correct the geometry and appearance of printed part, enhancing its quality. There should be more research in terms of novel materials such as steel, fibers, fiber meshes, etc., to improve structural safety and reliability. On the other hand, the use of smart materials such as shape memory materials and self-healing materials together with embedded system will make building responsive to multiple stimuli adapted environment. There are limitations to produce optimized material components in terms of shape and topology and material composition. In addition to construction, several heterogeneous components respond to one purpose each, while functioning graded elements address multiple functions. Structural and functional properties can enhance using non-homogeneous functionally graded materials with continuous spatial changes in properties requiring fewer resources and producing less waste. The construction industry must adapt to technological innovation to respond to fast changing world. The digital revolution and shortage of skilled workforce are two critical issues accelerating this transformation. The rapid expansion of advanced technologies such as IoT, BIM, and other and digital systems are empowering a new digitalized construction industry. The so-called Construction 4.0, which promises to increase construction productivity, quality, cost, and resource efficiency. Thank you.
Thank you, Rohit.
Yeah.
Any question from the class? Okay, so if there's no further questions, please use the link in the chat box. All right, thank you, Rohit, again.
Thank you, Professor.
Okay, so after that, we will have 4 team presentations. So let's limit the time to 15 maximum for each team. And this is the smart building design proposal. Which team wants to be the first? Nobody? I saw Remy, you unmuted yourself first. Yeah, you want to be the first?
If Kazaki want to go first, we can go.
Yeah, okay.
All right, so which are team number?
Number 1.
Team number 1, that makes sense.
Yes.
Okay, guys, I'm going to share the link for this team evaluation in the chat box, and you guys can go anytime.
Kazaki, do you want me to share my screen or?
Yeah.
Yeah, I share. So we are team 1. I'm Kyosuke Kato, and Lami introduce our renovation plan. So our renovation plan for Weill Hall is to guarantee student and staff worker safety. So for achieve our purpose, we use following technologies to improve a Weill Hall, which BLE, which is Bluetooth Low Energy, and magnetic field sensor and CO2 sensors. At first, I would like to introduce Bluetooth Low Energy. Bluetooth Low Energy is a wireless personal area network technology. And this technology is low cost and long battery life and ease of development. So the picture in here shows the example of the BLE technology. We have already used this technology to when we lost our personal when we lost iPhone, we can search the iPhone by using the Bluetooth Low Energy. So for the renovation, we applied the beacon to the each room in the Weill Hall. So Bluetooth beacons are small radio transmitters that send out signal in radius 10 to 30 meters. And the beacon can detect signals from the device and recognize distance between them. For example, we have a cell phone. So our cell phone can the beacon can receive the signal from our cell phone and then provide the distance from the beacon to our cell phone. And also, beacon can also provide sensor data. So they may include sensor. They can detect movement with the people, and they can sensing temperature and humidity and air pressure and light and magnetism. The pictures shows on the left-hand side is the example of the beacon. The cost is $40 per each, so very cheap, cheap device. And also we have to the student or staff workers can, have to download application for use this beacon. So here's an example of the beacon.
I don't think you're sharing the right screen.
Okay. Okay, so.
There are a lot of moving parts, and I need to keep. I'm a busy guy. In my business, there are a lot of moving parts, and I need to keep track of them at all times. That's why.
Hey, have you seen Yannick?
He's in the kitchen. You want to know how I did that? With this, the new Contact.io location engine. The location engine, together with a new device that we call the gateway, allows me to know the precise location and health of all of my beacons. And it just so happens that Yannick has a card beacon on him, so I know exactly where he is in the office at all times. And I can even tell that he's been there for 30 minutes. Oops. Also, I can set it to alert me when Yannick leaves or enters the office with an email, a tweet, or even fill out a spreadsheet, all automatically. Pretty cool, right? But it doesn't have to be a person. It can be anything. A box, a forklift, a dog, anything as long as it has a Contact.io beacon on it.
Hey, how many boxes do we have left?
Let me check. 57, no, wait, 56. One just left. And it's all in real time and completely remote. So I can check my inventory, statistics, and all the data that I need completely remotely at any time of day or night. Sorry, you gotta go. You know how it is. I'm a busy guy.
So, right. In this video, they use the card type beacon for detecting the
What is the first
signals.
thing you need to figure out when planning a beacon deployment?
Well,
very often it boils down to knowing how many beacons you need and how you're going to deploy them. But it's a bit more complicated than that.
Okay.
Yeah, okay.
Okay.
And grid-based. Grid-based deployments are primarily used for indoor positioning, navigation, and detailed indoor analytics apps. These apps triangulate your position based on the signal from the beacons nearby. Such deployments require large amounts of beacons placed relatively close to each other to create a dense grid. They can be used in the...
Okay, I'm sorry. In this video, they can use the card beacon to detect the signals. So my idea is our UFID card to change this type of the beacon to detect our to send our information. And so the advantage of the BLE is the first is evacuation. In case of an emergency, it is then possible to determine the number and the position of the people still in the building and to evacuate them. And also, we can see the occupancy status by communicating with personal beacon in the room. You can find the number of the people in the room. And the final is the environmental condition. By monitoring environment condition in buildings such as temperature and humidity, keep a comfortable environment and reduce the risk of infection such as COVID. So from now, allow me to introduce our technologies.
I'm going to talk about the energy monitoring and optimization. First, why should we monitor energy? Because energy for heating and cooling and equipment operation is one of the largest expenditure in the business field, and we should consider when we going to reduce the energy, we should consider the occupant's comfort. So it's like strongly related. And to get intelligent building or smart buildings, we should use the Internet of Things concept, which connects all sensors together and improve our buildings. Next slide, please. So monitor energy, we are going to use this measuring unit, energy measuring unit from up to 22. This will cost about 1,750 for the unit. Advantages for this unit is the real time, and we can do historical data logging. It can be accessed through smartphones, computers, and also we could use API, application programming interface softwares, to communicate with this device. Also, it could be communicated through wireless or Ethernet. So there is multiple options. Next slide, please. So basically, this measuring unit, we can connect it to the power panel. And then we get the readings for the energy usage that in our building. In order to do that, we need to get a small device, the current transformers that's in the right top side, to connect this device to the power panel. And also we can connect this device to smaller applications to get the readings of the usage. This device comes with a free program that we can upload also from the company to monitor and measure the energy. Next slide, please. So for the emergency system uses basically sensors to identify hazards and provide safe path for users. As Kausak mentioned, we could use Bluetooth sensors. We could use different type of sensors to identify hazards, identify locations of people, and provide information or safe areas that can go to. Next slide, please. So for our emergency system, we are gonna use the CO2 sensors here that provided by the CO2 meter company. Basically, we're gonna detect the CO2 level in fire cases, fire situations. If there is increase of CO2 level, of course there is a fire in that area, so we can locate people to different side of the building or different exit of the building. The advantages of this sensor: real-time measurement of CO2 levels, relative humidity, and atmospheric pressure. Data can be accessed through smartphones, PCs, and of course API softwares, which allows us to connect this sensor with other sensors, maybe the beacon sensors, and also the other sensors to make this building smarter. This sensor is battery design based, so we can put it everywhere. And the most important feature in this sensor, we can identify zones for this sensor. So let's say we put this kind of sensor in main exit locations and in main location in the building. So we can identify, let's say stairs number 1 is high CO2 level. So the fire in that area we should locate people to the next stairs or next exit place. Next slide, please. So as a conclusion, connecting sensor is very important. We should to get smart building, we should connect all the sensors that we have together through wirelesses or different type of systems, and use programming languages to improve the uh, efficiency of our system. Beacon and CO2 sensors can provide crucial information that we could use in emergency situations. And finally, for the approximate cost for this kind of renovation, it will cost about $30,000 if we assume that we use 10 measuring unit for energy in the building, and if we use about 100 beacon sensors to locate people locations, and about 20 sensors of CO2 sensors that will be located in major areas to identify the CO2 levels. And thank you for listening.
Thank you, guys. Any question from the class? Just a quick comment, maybe not question. So maybe it's like I mentioned earlier, the CO2 sensors can also be a way to check the occupancy, right? So maybe there's another, maybe you guys can think about it also solution to make use of one sensor data to infer different information about the building, right?
Yeah.
All right. So thank you again. So this is team one, guys. Please use the link in the chat box to evaluate team one. And I saw in the chat box, Abraham, you want to be the second team, right?
Yes, please.
Okay, you are okay to go anytime. What's your team number?
Group number 3.
Number 3. Okay. All right. Let's do it.
Hello guys. Good evening everyone. So today me and Abraham are here to present our assignment. It is basically to see the ways to improve or make Weill Hall a smarter building. And so let's get it started. So first let us know about few things about Weill Hall. Weill Hall was constructed in different sections between 1947 to 1949, and in 2008 it was added to the United States National Register of Historic Places, and it was also named after the dean of the College of Engineering, who was Joseph Weill. And now currently we use the Weill Hall building as a building for Department of Civil Engineering as well as Industrial Engineering. So we know that it was built in 1947 or 1949, but still they made sure that it was a right environment for students to study and perform their tasks and everything. So let's see some of the ways where we can uh, make it a smart or a better place again. So the renovations, what you have included is indoor air quality monitoring, indoor localization, occupancy status, energy monitoring and optimization, and also emergency systems. So coming on to the indoor quality monitoring, we have used a Wi-Fi air quality monitor, as you can see in the image over here. So there is a air quality tester, which has built-in sensors which can actually measure the parameters which affect the air quality, like particulate matters, carbon dioxide, temperature, humidity, and so on. So it is very easy to connect to your phone, and whenever the particular item goes over the threshold, you will get a notification. And also it has a built-in battery which can be used in case of power cuts or power shutdowns. And the major advantage of using this technology is, again, like you can check the air quality from particulate matters to carbon dioxide. And if any of these like I said, if any of these parameters exceed the threshold, we can easily evacuate the people from the room or the building and keep them safe without causing any health issues to them. So far we don't have any such issue of air quality in Weill Hall, but it is just for the safety reasons we can make better use of this technology or the sensors. And moving on to the next one, like the indoor localization. So we know that we don't have the traditional in-person classes, mainly because of the reasons of the pandemic which is caused, and it is really hard for us to socially distance from each other when we are at class. So this is one of the sensors which can help us uh, not completely solve that issue, but still up to an extent. So this the is SDS sensor, which is used to maintain a distance of 6 feet uh, between two individuals, and it is easy to carry, fits in your pocket easily. And the way it works is uh, like anyone entering the building will have a SDS tag on them, and if they come in contact or within 6 feet of any other person, the device vibrates or it shows a light and makes a noise, like alert them that there's someone within 6 feet of you, so you can socially distance from them. And it it it, it is a it has a good accuracy uh, as it uses the ultra wideband technology. The advantage of this is we can easily follow the guidelines to maintain the 6 feet apart distance, like when you're working in a excuse me, when you're working in a closed space. Because of this we can also help or contribute to reducing the spread and make sure that people around you are safe. And this can be of great use at Weill Hall, where like in these situations there are people who want to work in labs and they cannot actually socially distance from each other. And there is one good technology which we can implement in Weill Hall. And moving on to the next one, which is the occupancy status. So we are using the motion sensor light switch, which is a three-way switch, and it it turns on the light when there is uh, someone around moving in the area which it covers. Like this light switch covers up to 380 square feet, and also it is designed to work with all different bulbs as well. So the advantage of the sensor is that you can switch the lights on when it senses that someone has the room occupied. And it also helps in reducing the energy consumption again, and in turn saving costs as well. So this can be of great use when it comes to like the washrooms or the classes which are having their lights on throughout the day or night. um, and if we use this motion sensors, we can reduce the consumption of electricity and energy. So it is also like contributing to the environment as well as for the cost benefits. And Ibrahim will take over from here.
Hello guys, continue what Hari just mentioned. So the fourth function is related to renovating Will Hall building. Is related to energy monitoring, which is sense energy monitor. And this technology, this sense is attached to the electrical panel, and it is connecting to the cell phones to show all the devices and machines that's inside the Will Hall, and they can figure out the consumption of their electrical. So it can also show like microwave was on for 2 minutes and the washer was on for 24 minutes. And it can also, in this picture, they can figure out the usage of all the devices inside Weill Hall, the weekly usage, the monthly, and the yearly usage of this through their smartphones. And it's basically it's can just send the notifications through the smartphones just from this device, which is connected to the electrical panel. So it basically takes current and voltage measurement over 1 million times every second. Then it drives the electrical signature of individual devices. So in addition to it will save money and it reduce the waste of electrical. It also avoid disaster. Knowing what's happening in the building in handy, Sense can give you a warning of problem before they get out of hand. So the last technology related to emergency system, which is safety wireless system security, and these small pieces are connecting to the first floor of Weill Hall buildings and attached in the windows and the doors, and it can immediately alarm while thieves pushing the door or windows, and it's easy and convenient to install, and it has a low power consumption and a long working time. So lastly, the cost estimation of all these technologies and sensors. So the Wi-Fi air quality monitor, each one is about $93, and we are assuming there are 100 rooms inside Weill Hall building, so each room will have one Wi-Fi air quality monitor. And the second technology is the SDS, which or the social distancing sensor. Each one is $75. So we are assuming there are 3 labs in Weill Hall, and each lab there are 20 workers or 20 students working at the same time. So the total is 60 pieces. So the third one, which is motion sensor light switch, it reduces the energy by as much as 68%, and each one costs about $13. And we are assuming, since we are already assumed 100 room in Weill Hall, so each room will have one of this light switch. So the sensor energy monitor, it's the average user saves between 6 to 9%, and each one costs about $300. And if we assume the Weill Hall has 5 floors, each floor will have one. And the last thing, the safety wireless system security, it's quite cheap. It's the one just about $3, less than $3. And we are assuming there are 60 windows and doors in the first floor of Weill Hall. So the total cost estimation is about $16,762. And we think in this price, we can make Weill Hall buildings smarter. So in conclusion, the sensors and technology we discussed can reduce energy consumption by 5 to 20%, which is significant financial saving. And the sensors help in 3 things: identify overuse and underuse area in buildings, provides opportunity to optimize space utilization, and improve building efficiency. Sensors can detect building performance and activate maintenance procedures before an alert. And lastly, the data generated by these technologies provide a key insight that can be fed into planning and make use of resource more efficiently. This is our presentation, and thank you for your listening.
Thank you, guys. And I'm curious, both teams actually mentioned the indoor air quality. Are you guys concerned about the air quality in Weill Hall?
No, I actually mentioned that we don't have any problem till now. I mean,
Yeah, the reason I'm asking is I heard, I don't know if it's true, so maybe it's just rumor. The first level, not the first, the second level of Weill Hall, the other wing actually got some radioactive gas, the radon, and so from the stones, from the stones used as the building material. Once again, I don't know if it's true or not, but you could also smell the mold and everything.
Yeah,
Yeah, maybe we need to care about the indoor air quality in Weill Hall.
yeah, exactly. Because even we have construction going around in our campus, and you might feel like some particulate matter, like maybe 2.5 or 10 coming into our whale hall, and it affects our lungs as well. Like it's a good thing to have that.
Mm-hmm. Yeah, both team mentioned that. That's interesting. All right, thank you. So please, guys, please use the link in the chat box to evaluate team 3. All right, so I see Rahid, you want to be the third team, right?
Yes, Professor.
Okay, so what's your team number 4?
It's team 4.
Okay, all right, so let's start. Thank you.
Okay. So I'll share screen my. So can everyone see me? Okay.
So once again, that's indoor air quality, right?
Yeah. So we are team 4. It's me and Suyash for this team, and our motive is to let's make Weill smarter. That's what we say. So basically, we are talking about indoor air quality monitoring for a while in terms of renovation. So generally, people think that even if I don't go much outside, it doesn't matter what's the quality of air indoors. But in reality, that's not what it is. Science has proven before that the indoor air quality declines as the time goes on, and it becomes more polluted than the outdoors air quality. The main reasons for this are many pollutants impact indoor air quality, such as volatile organic compounds, carbon monoxides, particle matters, methane, and radon. The poor air quality is the cause of numerous respiratory ailments, including asthma, respiratory inflammation, decreased lung function, and cancer. Also, low air quality produces less human productivity. So this is a particular picture of Weill, and as you can see that there is lack of crosshair ventilation. Like most of the Weill, it's covered on both the sides, and we don't have space for fresh air to enter. So even that's one of the main reasons to install indoor air quality monitors because of lack of crosshair ventilation in Weill, and since because of this reason the indoor air quality is getting deteriorated again and again, and thus causing problems. So over here we have shown a table, like this was taken from the source as mentioned below, and it shows that average time occupied per week per classroom and semester as shown, and types of particulates that are seen around, as well as the concentrations of particulate in various areas such as common rooms, classrooms, and outdoors, as shown in these tables. So we mentioned about indoor air quality monitoring, and these are the sensors which we'll be using. So the one which shows the red symbol that indicates that the air quality is deteriorating, while the one showing green indicates that it's pretty good and you can roam around in that particular air quality. So this is how the whole system works. These are sensors. It is connected to a single board computer, and again it's connected to the Internet of Things, IoT triangles, as you can see in the picture. So indoor localization will be done by Suyash from here.
Thank you, Rohit. So we have a need of indoor localization nowadays because like it's a major focus in any kind of industry. And the most importantly, there is a need of indoor localization in the Weill hall because of its complex maze structure, and one can easily lose his track to reach to his destination. Rohit. So this is a typical active RFID tag, and this is an UFID tag. So we have a plan to install this RFID tag into the UFID, which is like available very cheap in the market. So it can track the location of an individual inside the while hall. So the working of this tags. So while most of us are familiar with outdoor geolocation technologies such as GPS, which is global positioning system, and but nowadays we are looking for an indoor tracking devices which provides an accurate geolocalization of objects or people. And in response to this growing demand and specific requirement, manufacturers of the IoT, that is Internet of Things sector, tend to develop more effective indoor positioning system. And if you can see in this figure, an active RFID system consists of tags and one or more interrogators. Every time a person or object equipped with a tag enters an interrogator's area, the interrogator activates the corresponding tag by means of low frequency signal. This process triggers a radio transmission that contain both the interrogator and the tag identifier. In terms of indoor location, active RFID can prove to be very
Is that
effective.
just me or everybody?
What happened?
Hello. So I think
Yeah, we can hear you.
Was it just me or everybody?
What happened?
We don't know what happened.
So I think I lost the connection for a couple seconds. Was that just me or was that everybody?
It was just you, I guess.
Okay,
Yeah,
okay, I'm sorry. You can keep going.
Yeah, so this all process triggers a radio transmission that contains both the interrogator and tag identifier, and a dedicated reader enables to receive and read such broadcast. Also, in terms of indoor location, active RFID can prove to be very effective, indeed by emitting low frequency signal. So this technology allows a great indoor localization throughout the area covered by the interrogator. Yeah, this has some disadvantages also, like they have very limited operative scope, but it is cheap in rate, so we can buy as many. And it need to be fixed with brackets to install readers and antennas. And network performance also depends on the surrounding environment. So this is the plan. So antenna will cost around 20 bucks. It's just for the one particular area. And because we don't know how much areas of the wild hall and what all the things are there, and antenna will cost around 20 bucks. So active RFID tags will cost around 0.99 cents to $20, and RFID reader will cost around $150 to $200. Now Rohit will continue with energy monitoring and optimization.
So basically, energy monitoring and optimization is the important need of the hour right now. Like we are looking to cut down the cost that which goes beyond in waste of energy, and it can be well utilized on other purposes. So basically, power factor as well as utilizes rebates to improve return on investment on energy products and procurements. So you can see a typical image of Weill Hall right now. It's a conference room, and in this image we can see that there is a lot of lightning. There is a lot of power wastage right now, and it's not even been occupied. So basically, a lot of energy is going to waste. And to solve this issue, we are going to suggest one particular thing, and that will be occupancy sensors. So how does a occupancy sensor works? So occupancy sensor is an indoor motion detecting device which can be used to detect presence of a person, and it can automatically control the light or temperature or ventilation systems. These are typically used to save energy and provide automatic control and comply with building codes. So the other thing which we will be suggesting for Weill Hall will be utilization of solar panels and using solar power as well, like to to save energy. So solar panel is something which helps like if you spend around, let's suppose, $16,000 for a while, after 7.5 years you will be able to get return of investment on that particular investment. So it's pretty much beneficial looking at a Weill Hall structure. Like we have ample amount of solar energy around, and we can always use that for the purpose. So basically, a solar panel system lasts for about 25 plus life year span. So installation costs for occupancy sensors will be around $50 to $300, depending upon what sort of occupancy sensor we are looking after. And cost of installing solar panels will be around $6,000 to $15,000, again depending upon the energy requirement which we have for Weill Hall. Similarly, the RFID tag and this occupancy sensors could also be utilized for other systems such as emergency status, to know about the emergency status of people in the Weill Hall building, as well as to monitor about the energy efficiency of that particular building. Yeah. Well, these are our references which we have used. Thank you.
Thank you, guys. Did you guys notice? You just reminded me of something. Did you guys notice that we are using the regular lights in Weill Hall, and I'm thinking we could save a lot by replacing everything with LED lights. Okay, so this is team 4, guys. Please use the link in the chat box, and now that leaves us team 2 for the final presentation.
Yes.
You guys can start anytime.
Okay, let me share my screen. All right. You guys see my presentation this time? Okay, so designing a Weill Hall smart building plan. So first things first, when we started doing this, we wanted to figure out what makes a building smart. So we looked around as well, and the biggest thing that stands out is an interconnected system via the internet. So we wanted to go around and figure out what we needed, and we decided on 2 major components. You need a system of Internet of Thing devices and an app to control all of them or monitor them. So going through, we decided on these 4 systems to connect, which are building occupancy, indoor localization, indoor air quality monitoring, and energy monitoring and optimization. So how do we want to make the building smart? So there's a lot of different sensors out on the market, and we wanted to go for a more cost-efficient and system. And as we don't really have floor plans for Weill Hall itself, we wanted to make a scalable design. So we decided to make an Arduino-based sensor kit that can be just multiplied for however many rooms or hallways you want to add to. So the first thing we have is building occupancy. I'm going to go over the physical part first. So a lot of rooms in Weill Hall that I remember, the windows are kind of blocked, or they don't really have windows into the rooms at all. And it's always awkward to, open the door and accidentally walk into a class. So one of the physical portions of ours would just be a simple indicator light on the outside with a button on the inside to, indicate if the room's occupied or not. And this would tie into an app, which is the more important thing. Through the use of the app, we'd be able to have an indicator status on every room, as shown here on the right. On the right, you got here a green little button would show it's like the room's going to be free. Yellow, it's occupied. It's going to be scheduled to be occupied in that. And red, it's currently occupied. Now I mentioned yellow, that's going to be scheduled occupancy. We want to tie into the classroom schedule because, hopefully COVID eventually does go away and we occupy the building again. So tying into class schedules would show students what rooms they're free to study in and form study groups. Because I often would go to classrooms myself with some friends to study for an upcoming test. So knowing what's already free instead of hunting down an empty room is super useful. Also with this, the computer lab in Weill, going through and trying to find which rooms are open and what computers are available is a pain sometimes. So we want to integrate this with the app just using student logins. When a student logs in, obviously its MAC address and IP show up as being active. Using that, we can tie in and just highlight whether a computer is active or not active in the app for students looking for workplaces. I'm going to hand it off to Junie, and he's going to continue.
Okay. John, could you please move to the next slide? Okay. I'm going to introduce the indoor localization. Weill has a problem of indoor localization since the regular distributed rooms in the building, and which are difficult to find. And this is especially for visitors and freshmen. So, as we all know, that GPS is an outdoor geolocation technologies that are widely known and used. However, satellite radio signals can hardly cross walls and other obstacles inside a building. And our team, we compared with multiple indoor localization techniques such as RFID and Bluetooth. Considering economical and practical problems, our team decided to use Arduino platform to create a kit of sensors that will be implemented in each room. And these physical devices called Node MCU. Based on this device, you can log in our Wi-Fi, and in this way, by this device, it can detect where you are and lead you to the room you want to go. John, could you please? Okay. You can use that smart app that John mentioned before, and you can install this app before you go to the Weill Hall, or you can scan a QR code next to the Weill Hall entrance doors to get this building map. And you search the room number you want to go, then the maps will show the floor locations and navigate you to the room you want to go. And this also ties to occupancy status. So if you click on the room to see this, you can click on a room to see the schedule, or reserve in that room for a time block, and then it will automatically activate the physical occupancy indicator and allows other students to remotely check the occupancy through this app. John, okay. And the next I want to introduce is indoor air quality monitoring. Based on latest industry recommendations for operating HVAC system with a focus on 4 key contributors to air quality. So we need to focus on dilute, exhaust, contain, and clean. For Weill Hall indoor air quality monitoring, our team plans to attach carbon monoxide, temperature, and humidity sensors on the room ceiling and wall. And this picture shows one of the sensors we're going to use is gas sensor MQ9, which can detect gas such as carbon monoxide, coal gas, and liquefied gas. And we're going to put that on the ceiling of each classroom. And the next sensor And the next sensor is temperature and humidity sensor, which gonna tell you the temperature and humidity, which is gonna also tie into HVAC system to automatically ventilate the exhaust air out of the room and keep us in a healthy environment. Next one, and John, could you please? Then I want to introduce our team for energy monitoring and optimization. This physical device is a group digital PIR motion sensor. This motion sensor would connect to Arduino and allow for efficient use of lights. For example, in the hallway, where we are not used for occupancy status, the lights will turn on if motion sensor detect body moves. And in other places such as classroom and labs, where we're gonna put on occupancy sensors at that places where motion sensor cannot detect body moves for a specific time, all electricity will cut off and turn into free status. John? Okay. What's more, we also gonna use this sensor and to use for indoor air quality control. And for example, when temperature sensor detect the temperature changed in room, and by the sensor, we can control temperature in a range such as 72 Fahrenheit to 76 Fahrenheit in the summer to save energy. And by using our smart app, you can also change the temperature room. You can change the temperature in a room by yourself, even remotely. Okay, and this is our estimate cost for the Weill hall, and we're gonna take $82.79 for each room. I think it's quite cost effective.
So I want to jump in real quick. These are unit costs based off of you only buy one. Most of these will lower significantly in bulk costs. So.
So you guys are done?
Okay. Now, I want to introduce a little bit about the smart building app our team mentioned before. We want to use this app and include these major features like an indoor localization navigation system that you can use this app to look the map of Weill hall and navigate yourself. And the next is a localized air quality monitoring system. And you can also use this app to check the air quality in the Weill hall, like the PM 2.5 and PM 10 and etc. And this third is HVAC optimized system. You can use this app to when the PM 25 or PM 10 is quite high, you can click on the app to the exhaust to release some exhaust air. And then the final is an occupancy status and room reservation system. Before you can come to the Weill hall, you can check the occupancy status of all classroom, labs rooms, like computer rooms, and And also you want to reserve a room, you can remotely to reserve it and arrive at your reserved time. Thank you. This is all of our team.
All right, thank you guys. Any question from the team? I noticed that a lot of teams actually propose to use Wi-Fi as a data exchange method, maybe like a localization method. But I also want to remind you, Weill has really bad Wi-Fi coverage. I don't know if you guys have that feeling. So maybe the first step is to boost the signal coverage inside of Weill. Okay, all right. Thank you guys for the presentations. And like I said, next week, we're going to talk about machine learning, cover the fundamentals of that. All right. I hope you guys enjoy your week. See you guys later.
Thank you.
Bye.
All right, thank you, Professor.
Thank you, Professor.